Hi, everyone. Welcome to the HTML5 deep dive. Well, deep dive into the HTML5 Canvas talk. I hope everyone's been having a great time at MIX so far. All right, let's start with telling you who I am. My name is Jatinder Man, and I'm the program manager for the Canvas and graphics features in Internet Explorer 9 engineering team. I'm also a member of the W3C HTML5 working group and have contributed feedback to the Canvas 2D context spec as a part of that role. I remember when we were developing IE9, we were creating these demos like Fish IE and Canvas Zoom, and it was just amazing to see the graphics that we could do on the web now with Canvas. And on top of that, the performance was, these sites just screamed in IE9. And I remember thinking at that point, wow, I can't wait till next year's MIX to talk about this. So here we are. Okay, so for starters, I just want to have an idea of how many of you have heard of Canvas. Okay, that was a trick question because the name was in the talk. So of course you've all heard of Canvas. Okay, how many of you have coded with Canvas? Okay, so that's about, I'd say, a quarter of the room. And how many of you have deployed a Canvas site? Okay. I see 2 or 3 people from the IE team. Perfect. Excellent. Okay, so I'll tell you what I plan on talking about today. I'm going to give you a brief intro into what is Canvas, talk about when to use it. Then I'm going to get into the deep dive and the nitty-gritty details. We're going to talk about the security model, the drawing model, accessibility features, interoperability differences, and best practices for performance and coding. So my goal with this talk is I want you to leave here excited about Canvas, excited about trying out Canvas, and actually going home or to work and building a site with Canvas. Okay, so what really is Canvas? Canvas is an HTML5 element that allows for 2D graphics. So it allows drawing of 2D shapes and images. I like to think of the Canvas as a scriptable way of updating a bitmap. Canvas is a immediate mode rendering as opposed to retain mode. And I like to think of immediate mode rendering as a fire and forget model where you draw graphics to the screen and then you have no context into what was just drawn. So the Canvas API is super simple. It's only 45 methods and 21 attributes. That's it. The point I want to get across here is it's really easy to learn. That's only 45 methods. As a matter of fact, here it is. No, I'm not going to go through each and every one of these. That's not the point. The point here is this is it. This is the whole Canvas API. It doesn't take long to learn Canvas. That's one of the advantages of it. Okay, so moving forward, I want to make it clear that Canvas doesn't remember what was drawn onto the screen. The analogy I like to think about is Canvas is like a child with a crayon. You can do a draw operation, and your next draw operation will just draw on top of the last. So everything is a draw. To erase, you have to draw some more if there was a perfect white crayon. It's the web developer's responsibility to keep track of what's the current scene and what the next scene is going to look like. This is the nature of immediate mode rendering. Okay, so with that, let's jump into a few demos. That's always an exciting way to start. So the first demo I want to show you is called Firework Interactive Video. And in this demo, you can control the mix of Mike Tompkins' latest video of the Fireworks song. And let's take a look. Okay. So let's go to the site. Let's let it load. Okay. So here you can see that there's little video clips of Mike playing different parts of the songs. So you can see he has like different like ahs and oohs, and if I go ahead and I zoom in on one of these, You can see he's like actually chewing some gum there. And the point in the demo is I can actually increase the knobs. Getting some video issues there, but as I increase the size of some of these, as I change the mix, you can see certain video clips are getting larger and smaller. So, okay, I gotta turn off the music. It was really annoying. So that site was entirely created in Canvas, all of it. And the cool thing is, Canvas enables, with hardware acceleration, new graphics-intensive interactive experiences that before were just not possible or very, very difficult. So like previously where I would have just had a knob to change my audio mix, I actually have a little video of the performer performing different parts, and I can change that. So really cool experiences that are just enabled with Canvas. So the next site that I want to show you is of a local radio station in Seattle called KEXP. Now, KEXP has a very large archived data set of favorite playlists played by their DJs. So they have this very large archive, and they use Canvas to give a nice pivot on that information so you can sort through it. Let's go to this site. So here you can see all these cool album covers, and this is essentially per DJ their favorite most played album. So like I can click on one of these, and you can see how many times the DJ played this song. Now I can also do some other cool stuff like give alpha transparency, scale these guys bigger and smaller, rotate them. I can even go ahead and play a video in the background. So this is all in Canvas. Further, I can sort by date, and I can see all the music, favorite albums of that month. Click there, I can break it down to per day of the month. Go ahead, I can break it down per day. So this is an enormous data set of music. And with Canvas, I can now do these really cool transitions and visualization effects that were just very, very difficult before. So you can imagine in a pre-Canvas world, I would have been like a Google search page with all these playlists, and it was kind of a boring task looking through it. Whereas with this site, they've made it into a really fun thing to do. All right, so let's look at a really simple example now. Let's draw a blue rectangle on the screen. Okay, so I'm going to show you how I did this. It's very simple. So let's look at the source. So you can see I have a HTML over here, and in my body I have a canvas element, and I gave it a name. I called it my canvas. And in the body onload, I call this initialization function. And here I grab the canvas, get element by ID, and I check if the canvas exists, and I do feature detection. I check if the get context, if a context exists, if canvas is supported in this browser. And then once I have that, I can get the context, I can give a style, call it blue, and then I'll call the fill rect, give the top left-hand corner, and give a width and a height. And that's it. That's all it took to draw something. Okay, so I'm going to show you one more site. This is a site I created in the IE test drive site. And it's essentially a tutorial site or a reference site. If you haven't used Canvas before or you're new to it, this is a good site to check it out, see what Canvas enables. On the right, you can see the canvas itself. On the left, you have a script console. It's actually editable. So if I go ahead and change the color, just change that to 0, not O. Execute, so you see the color changed. I also have a reference to the spec right here, and the API is there with a description. So let's look at a few things that Canvas enables. So we can do rectangles, as I just showed. We can do circles. We can fill the circle. We can give it an outline. We can do quadratics. I painstakingly drew this E. A line here, quadratic there. I can do Bezier curves. That's how I felt afterwards. I can do a spotlight effect. I can create, like I drew painted black, and I have this clip, and I'm moving it on a timer, and it's creating the spotlight effect. Likewise, I can do colors, as we all know, as I just showed. I can do fill style, stroke styles. gradients, it's my little kite, patterns. We can do line widths, caps on the line, joins, how the lines bend, shadows, text. We can also show images. So this is kind of cool. I can use cross-domain images or my own images, and I can draw them onto the canvas. Furthermore, I can change and manipulate the pixels on the canvas. So we'll talk about that a little bit further on, but that's really cool. I can also do the same with video. So here I have a video, and I'm drawing it onto the canvas. And as you can imagine, I can look at the pixels and change the colors, make it all green, freak people out. I can also do rotations, like transformations. Like in this case, I drew a single square rect, and I rotated it to create this effect, scaling. I can even play with the transformation matrix. In this case, I drew the E once, and I used this transform. It's funny how it's bouncing. And I created this effect. Also, I can do animations. OK, so that's cool. Let's get back to the talk. And so now you know what Canvas does. And taking everything we just talked about, you can bring it together and do scenarios like gaming, like Pirates Loves Daisy. That's a game made entirely in Canvas. We talked about the visualization effects. You can do interactive charting, graphs. You can create mapping using Canvas, intensive graphics. You can also do web advertisements because, as I'm going to get to later on, you can import, you can draw images, videos, and other things. So you can also see the killers have a HTML5 site. They use SVG and Canvas in parallel together, complementing each other to create this panoramic effect. So that's cool. Those are all the things you can do with Canvas. So let's jump into the deep dive. Let's talk about some of the nitty-gritty details. So let's start the talk with the Canvas drawing model. So the drawing model specifies the order and steps a browser takes to draw images, shapes, clippings, shadows, compositions onto the canvas. Now you might wonder, why do I care? This is important to a web developer because if you know how the browser's doing these steps, you'll get some insights into performance, like what operations are more expensive and which ones are cheaper. OK, so I'm going to give you an example here. We're going to draw this yellow smiley, and it's created by using the Bezier curve I mentioned earlier. Give it a shadow, a 50% transparency. You can actually see, like within the smile, you can see through it. And we're going to give it a clip. So it's actually drawn on a yellow background, give it a clip. And we're going to use a source over composition. Now, source over is the default composition mode. I'm going to get into details about composition modes a little bit later on, but you can think of it as a default drawing operation. OK, so what the spec specifies a browser should do is you first, like if this is the canvas, we first create an intermediate image A. And this is in the background. This is what the browser is doing. And this is the size of the entire canvas. So if you can imagine having a very large canvas, you would have a very large intermediate A. And on this intermediate A, I draw the yellow background and the Bezier curve. Next, if I have shadows, I create an intermediate B, and I draw the Gaussian blur, the shadow, onto intermediate B. So the point that I want to make here is for a shadow, you're creating a secondary intermediate. Next, we give it transparency effect. So here I'm applying the global alpha, the transparency, by 50%. And finally, I clip the intermediate B. And now I draw it to the canvas. So I'm compositing it onto the canvas. Likewise, I take my intermediate A, I give it an alpha, 50% transparency, I clip it, and now I draw it to the canvas. So the point that I want to make here is that certain operations are more expensive, and I'll get into them in a moment. But as you saw, certain operations require a second intermediate. Now, if you have a very large canvas, this will be costly. i9's implementation actually optimizes one step. When we draw the canvas, we create intermediate A with the transparency already as a part of it. So it might not be very clear here because it's hard to tell if that's original. But this has the transparency effect already applied. So when we create intermediate B, we do the same thing, give the Gaussian blur. But because we've already done the transparency, we save a step. We can just go ahead and clip, composite it onto the canvas, and once more, clip intermediate A and composite it onto the canvas. Okay, so the learning lesson here is that certain operations are more expensive than others. Not all operations were created equal. So the thing that, like, as you could just see, is like shadows, clipping, transparency typically are more expensive. In IE9, the transparency isn't. So you should be careful when you're drawing a very performant application to be very careful how you use these guys. For example, imagine a scenario where I was drawing 1,000 little stars. Instead of drawing 1,000 little clips everywhere, that would require, if I'm doing this on a loop, I would be creating an intermediate every loop. What I should rather do is create one big clip, like one big stencil of all the stars that I want, and create a shadow there, because I'm only using one intermediate. So keep that in mind when you're creating performant applications. Okay, so let's talk about composition operations. So as I alluded to earlier, composition operations are like a child with a crayon. You do a drawing operation, and your next drawing operation just draws on top of the canvas. Even to erase, you must draw some more. So these rules can be changed, and that's by composition operations. Canvas defines 11 composition operations, and why don't we go ahead and look at a demo and see what they look like. Okay. So what I'm going to do here is I'm going to draw a destination image. It's going to be a blue rectangle. I shouldn't have done that. So I'm going to draw the blue rect, and then I'm going to apply a composition effect. And finally, I'm going to go ahead and draw the source image, which is a red circle. So to recap, draw blue rectangle, apply composition effect, draw source image. Okay, so let's look at the basic composition, the default, the one I alluded to earlier. Okay, so this one, in this case, I'm just displaying the source image wherever the source image is opaque, and I'm displaying the destination image everywhere else. So this is the default common painting operation. So we can change this. So let's take a look at another one of these operations. Let's look at source out. So in this case, I draw the source image wherever the source image is opaque and the destination is transparent. I draw nothing else. So as you can see, in this case, I've actually changed what was previously drawn on the canvas. The blue rect is no longer there. So compositions allow me to change what I had previously drawn on the canvas. Likewise, source in is wherever there's an intersection between source and destination, I draw the source. Source atop is kind of similar, except I leave the destination in. Likewise, there are certain operations for destination, the inverse. For example, destination in is the inverse of source in, and in this case, leave the destination wherever there's an intersection between the two. Destination out, similarly, is opposite of source out. And destination over is kind of interesting. In this case, I'm drawing the source underneath the destination. So the second operation that I drew appears as if it was below the first operation. So this might be a good time to bring this up, but composition operations aren't blend modes. You're doing bitmap operations. You're drawing one bitmap on top of the other. If you have a transparency in your shapes, you'll see a kind of like a blend happening, but it's really a bitmap operation, except for lighter. In this case, we're actually adding the sum of the pixels, the colors, for wherever there's an intersection. Finally, we have copy, which is literally only draw the source image and not the destination. We have XOR, which is the exclusive OR. Okay, so let's look at another example. So you've all, I guess, most of you may have seen this Seurat painting. And what I've done here is I've cut this painting into two parts. And with a source over operation, they look like it's one painting. It looks like one piece. So let's take a look at different composition operations. Okay, so I'm looking at source out. So that's interesting. What just happened there? So now you can see a different view. And if I go to destination over, you can see a different view. So I'll break into what happened here and how we got Homer on the screen. So the source image was the original painting. And what I did was I removed the middle part and gave it transparency. And the destination is this different image. So I'm sure you can think of other composition mode scenarios, but here was an example of having two images via different composition operations. I saw a different view on things. Okay, cool. Let's get back to my slides. Okay, so my second tip of this talk is that Firefox, Opera, and IE all implement the drawing model as I just described. However, Safari and Chrome, the WebKit browsers, actually implement a slightly different drawing model. Now, the difference is so subtle that it only appears in 5 of the 11 composition operations. So be aware when you're using composition operations, because I can imagine a scenario where a web developer is using composition operations designed on IE or Firefox, and did some sanity checks on Chrome, but not a whole lot. And when the product was done and you looked at Chrome, and it just looked different, and you can't figure out why. So this might be one of the reasons why. Okay, so let's go through the differences between the spec and the Chrome and WebKit implementation. So on the left-hand side, I have the IE implementation. And on the right-hand side, I have Chrome. And as you can see, most of the operations look the same. So what I'm doing here is I'm using my blue circle, red square, wait, all the way around. Red circle, blue square example, except I gave the red circle a shadow, and I gave it a transparency effect, so you can tell the differences. So you can see most things look the same, except the boxes highlighted in red are actually different. And it might be clear from these examples that the WebKit browsers don't erase what was previously drawn on the canvas. So they believe that you shouldn't erase what was previously drawn, because with Canvas, it appears that everything is drawn to the next operation. So interesting story, when we were developing IE9, we released most of our implementation with Platform Preview 3, except we didn't release the composition operations until a little later. So I'll explain why. And the reason was we were debating whether the spec as written is correct or whether Chrome and the WebKit browsers, Safari, were correct. So we met with a lot of graphics experts, we discussed this, and we finally came to the conclusion that the spec as written is correct. And the reason is, well, one reason, the spec was based off a paper by Porter and Duff. And in the paper, it's very clear that certain composition operations can impact what was previously drawn on the canvas. For example, if you look at the Chrome example, you'll see that source over and copy look identical. And if we had removed the transparency from source out, and source out and copy would also look identical. Okay, so keep that in mind when you're doing composition operations. Let's talk about something else for a moment. All Canvas attributes are global. So whatever attribute you change will impact every future drawing operation. So in this case, I wanted to write the text winning. This felt good. And I wanted to give it a shadow, but I didn't want to give a shadow to the outline. I just wanted to draw a simple outline. But as you can see, I applied the shadow effect. I wrote, fill text, and now my next operation, the stroke rect, also has a shadow, which is really annoying. So what you would do here is you would wrap your functions in a save and restore APIs. So you can use save and restore to save the current state of the canvas. That means you save the transformation matrix, the clipping region, and most attributes. And what you would do here is you would save the current state of the canvas, make changes, and then restore the previous state of the canvas. So the correct way for me to have done this would be to save, then make the shadow change, then do the fill text, and then restore the previous state of the canvas. Now I can draw the outline without it having a shadow. Okay, so let's move on. Let's talk about the next thing. Let's talk about interoperability. Now, interoperability is very important. We've all been in this situation where we designed a web page in one browser, went to check another browser, and we find that our page isn't working as expected. And then we have to do these workarounds, and we still know that we have to test even more more browsers. So we designed IE9 with spec compliance in mind and interoperability in mind. We try to make our implementation as interoperable as possible. However, with all browsers, there still remains certain interoperability differences. And I want to call this out so you guys are aware when you're designing Canvas sites what to look out for. Okay, so there's good news. There's a high level of support for Canvas across all browsers. That means in mainline scenarios, you can design a web page, and it will just work across browsers. It's like a same markup kind of principle here. Well, more like same script. I think I'm having too much fun with the pictures. So let's take a look at Philip Taylor's tests. Now, Philip is a member of the W3C, and he's written all these test cases to test Canvas. And he's written some 700 plus test cases to test browsers' implementation of the spec. And he's in the process of submitting these to the W3C. And as a matter of fact, Microsoft's helping review his test cases. It's a part of the W3C process is someone else has to review your test cases before you can submit. Now, the cool thing is when you run his test cases on all the modern browsers, you'll notice that we have at least 80% or almost 80% support across all browsers. So you should feel good about designing pages with Canvas because you know your mainline scenarios will just work. Now, the remaining 20% across most browsers are just edge cases. So I'll cover a few of those right now. But you should feel good that in most mainline scenarios, you can just design a page and it'll work. So the test cases that I'm showing you here now are on the IE test drive site. And these are test cases that IE has submitted to the W3C. So our approach is write test cases and find cases so that we write these comprehensive test cases that other browsers can use and test the spec so that whenever there's cases of interoperability differences, they can either change their implementation to make sure that it's interoperable, or we can discuss and figure out how to update the spec. So here's a case of tests that we found where other browsers were doing different things. Like, for example, composition operations we just talked about. Shadows doesn't really work so well with images in Chrome, and certain other examples. So you can take a look at this. You can go to the IE test drive site. But the key point that I wanted to make here was that most mainline scenarios just work. There's some edge cases. You as a web developer should be aware of those edge cases so that when you hit them, you'll know that this was a problem. You don't waste too much time. OK, so let's move on. Let's talk about the security model. Now, the thing I want to make clear is Canvas already has built-in protection to keep you secure. And I'm just going to go through what that protection is now. All right, so Canvas allows reading and writing of pixels to the screen. We all know about that. You can also save pixels that you wrote to the screen. For example, here is my smiley face that I just drew to the canvas. I can use my toData_URL method, get a data URI, and output this as an image. So Canvas gives you the ability to save whatever was the current state of the canvas as an image. OK. So Canvas also allows drawing of cross-domain images and videos. However, Canvas has built-in protection for the scenario where someone tries to save those images. For example, I can draw cross-domain images. But the moment I go ahead and try to save this, the security error exception is raised. So let's look at an example of that. Well, before that, let's talk about, so this protects you against information leakage. And information leakage is the scenario where scripts from another origin are trying to copy data from your site. So we protect you against that case. OK, so let's look at an example. I used to bank with Contoso back in the IE7 days, but I recently switched over to Woodgrove. And essentially, the reason I switched was these guys do a really good job of check images. And so let's take a look at an example. So in this example, if I go to this site, my browser saves my login information as a cookie. And when I go to that site, my browser has a cookie, and it knows, OK, I can show this particular check. So if I go to that URL, ID 0001, my browser gives a cookie, and then I can see this image. So in this case, I went to Burger Queen last night, spent a lot of money there, and let's hope the king isn't divorced. So the point that I want to make here is this is great. I can look at my images. This is all good. But the site isn't so great. Looking through multiple checks is very tedious. I have to go through menus. So I went ahead and I designed my own page. I went to jatindersman.com, and I created my own application. So what I do on this site is I know the URLs to my images, and I have a cookie, so I can pull these various cross-domain images. And I can sort through my checks, and I feel really good. I can do all this stuff. Now, I was having such a good time with this that I told my friends, and my friends started using my website. Now, essentially, anyone that banks with the same site and has the same cookie can also pull their images. Now, what if I use my site to save their images to my desktop, to my machine? So Canvas protects against that. You can't save images. You can't save the state of the canvas the moment you're using cross-domain stuff. Okay, so let's look at the technical details around that. So Canvas has a concept of an origin clean flag. It's true by default. The moment you use a cross-domain image, video, or you use a canvas, because you can draw other canvases to your canvas, or if you use another canvas that has a cross-domain image or video, your origin clean flag goes to false. Now, so that's fine. You can still draw things with an origin clean flag of false, but the moment you use one of these two APIs to data URL or get image data, a security error exception is raised. Okay, so let's look at an example of that. In this case, I've created a new image. The source, as you can see at the bottom, is an other domain. So in my onload function, I'm drawing this image. And at that point, everything's cool. I can draw this image. That's fine. But the moment I try to save that image, a security error is raised. Okay, so that's cool. Let's move on. Let's talk about accessibility. Now, accessibility is important from a global citizenship point of view, and it also may soon be the law. Last July, the DOJ indicated that they're going to move ahead with making the Americans with Disabilities Act applicable to the web. So as web developers, you should be aware of accessibility features and how to make your Canvas site accessible. Okay, so let's take a look. When we started developing IE9, there was no standard for accessibility around the Canvas element. As a matter of fact, we contributed to a proposal in the W3C as a part of the accessibility task force. And the spec now has two accessibility features. IE9 Beta was the first browser to add support for one of these accessibility features. So let's talk about the two features. So the two features are fallback content focus. And if you follow the W3C mailing threads, they actually refer to it as shadow DOM sometimes. Sounds a bit ominous for me. But what this feature does is allows you to, when you have embedded content in the canvas, it can be keyboard focusable and viewable via accessibility tools. I'll get into that in a second and let you know what that really means and clarify. So IE9 is currently the only browser that supports this. The other feature is focus management. And now, so this has been really recently added to the spec. I like to characterize it still as somewhat unstable because changes are being made. No browser currently supports this. But the idea here is you can have a focus ring on certain parts of your canvas that correspond to embedded content. Okay, so let's talk about what that means. As you all may probably know, whenever you write content within the Canvas tag, that's treated as fallback content. If your browser doesn't support Canvas, the fallback content is displayed. So the canonical example here is your browser does not support Canvas text there. But you can also imagine a scenario where you're showing Canvas in a Canvas browser, and in a non-Canvas browser, you have a different implementation or some text or image there. Now, when you have a canvas, whatever's in within the tags is no longer shown. So this was a good opportunity to use that space for accessibility. So you can put content in there, and if you wire up your canvas correctly, you can give your keyboard events that correspond to what's visibly happening in the canvas and also to what's happening to elements within the canvas tags. And accessibility tools can look at that. Okay, so let's look at a demo. The demo that I'm going to show you is it's a web form written entirely in Canvas. And the way it's wired up is there's another web form within the Canvas tags, and which isn't visible because it's within the tags. And the keyboard events are getting sent to the web form both on the visible canvas and also within the DOM. So this demo, I actually haven't created it myself. One of our testers wrote it. And this is also probably a good point to bring up another point, and that's Canvas enables a lot of intensive graphics experience. But with great power comes great responsibility. And you'll know what I mean in a second. So voila, here it is. So I don't know if it's bothering you, but that green radiant really gets at me after a while. Oh. Voila! Now you know what I've been talking about. Okay, so here's a web form, and essentially what we can do here is I can tab through this web form, and if I hit spacebar, I can check the checkbox. And essentially, the way the canvas is wired up here is there's also a web form within the canvas tags, and that's also getting the same event. And if you're looking at an accessibility tool, you can see that. Now, I'm actually not going to open up an accessibility tool, but you get the idea here. Okay, I'm going to really change that screen. Okay, cool. Switching back to the presentation. All right, let's get into the best practices. Let's talk about what are best practices for coding and also best practices for performance with Canvas. Okay, so the first thing I want to talk about is feature detection. So if you're doing browser detection within your code where you're giving non-Canvas implementation in the case that you detect a particular user agent string, you may be blocking HTML5 content from displaying in future versions of that browser. So you shouldn't do browser detection. Instead, what you should do is you should check if a feature exists before using it. So check if that API exists, and then use it. This eliminates the need for you to make assumptions on the current browser support, and also ensures that your site continues to work in the future so that you don't have to make any changes. So again, I showed this earlier. Here's an example of where I create a canvas dynamically. I check, does that canvas exist? And I also check, does that context exist? If it does exist, I put the code requiring canvas there. And if it doesn't exist, in the else statement, I put the other code there. Okay. Also, add a doc type. So if you don't add a doc type to your page, your browser may fall back to Quirks mode. Different browsers may act differently. And in Quirks mode, you may or may not have the latest standard support. So it's good practice to always throw in a doc type. I personally prefer the HTML5 doc type because it's very simple. But you can go ahead and use the strict doc type. This ensures that your browser treats your web page as the standards web page. So in IE9, we actually only support the canvas feature in standards mode. And we've taken this explicit design decision to ensure that legacy standards mode, legacy modes, document modes, continue to work and are fully backwards compatible. So it's interesting because when we were developing IE9, I kept a list of all the sites that were using Canvas. And this was great because we could test our implementation with existing sites to get an idea of bugs, make sure we fix things. And one of the key reasons things broke was always, not always, but was very commonly the doc type was missing. So the page wouldn't render. The moment you put in the doc type, everything would be fine. So it's a common mistake. Make sure you put a doc type. Your page will work fine. If you're looking in IE, you can hit F12 and you can see the dev tools. And you can see that there's a document mode listed in the menu item. OK, so let's talk about performance best practices. So for the last 8 years, every Windows machine has shipped with both a GPU and a CPU. Also for the last 8 years, well, about 10 years or so, GPU's processing power has grown exponentially at a rate higher than CPU's. Now the sad thing is most applications don't actually make use of the GPU. So when we were looking at the HTML5 spec, we read the spec and we saw potential for using the GPU to improve performance. And we implemented our implementation of HTML5 with the GPU in mind to make use of the graphics card. So the tips, some of the tips that I'm going to be telling now are around hardware acceleration and best practices. Okay, So any browser that implements hardware acceleration on Windows will probably be doing so through D2D. And using D2D, it's expensive to read and write video. Like reading and writing directly from video memory is slow. So you should avoid doing get image data or put image data calls repeatedly. Instead, you should request a larger area of data with fewer calls. So let me give you an example. So in this example, I have variable x and y. I'm doing a loop through every single pixel in the canvas. Now what you could do is you can say, variable input and ctx get image data there and get one pixel at a time. Except now you're doing image data calls per pixel. And this is very slow because we're going directly to video memory. Instead, what you should do is you should get your input up front. So you get your image data with all the pixels that you require. And then put that into a JavaScript object, manipulate the JavaScript object, and commit it back. Likewise, committing back, you should queue up all your changes that you're going to make and commit back once, rather than committing every change after every pixel, because as I said, calls to video memory are slow. Okay. Likewise, a similar tip is for getting the pixel array. Don't access the image data.data array directly, because that requires a DOM access to fetch and index the object. So this is a very common issue I see on a lot of sites doing pixel manipulation. A lot of folks are directly playing with the data. And so don't repeatedly call that. Cache it into a JavaScript object. For example, here's a don't example. Don't, in every single pixel call, manipulate the image data.data directly. Instead, what you should do is you should cache it into this var input data, which is a JavaScript object, manipulate that, and then commit it back once. Again, same issue goes for committing back. You should queue up all your changes and commit back once. Okay. So any browser that implements hardware acceleration on Windows would probably use D3D textures for canvas objects and patterns. So again, canvas objects and patterns, creating new D3D textures is slightly expensive. Don't create them on every frame. Instead, what you should do is you should reuse existing patterns and objects as often as you can. Okay. So in the case where you're using patterns and objects, this tip might be useful for you. It's a common scenario to apply the canvas width or the height to itself. So you set the canvas dimension to itself, and as the spec states, that actually clears out the canvas. And it's a common coding practice to set canvas width equals width kind of thing to clear the canvas. But what happens here is if you're using a lot of objects, they get wiped out. So every frame, if you're doing this, you're going to wipe out all your patterns. It's going to be expensive. For some reason, your app is going to be slow, and you won't realize why. So instead, what you should do is you should use ctx clear rect if you have a lot of objects, and clear that. That doesn't delete the textures. Okay. So my next tip is about reusing canvas objects. Again, it's cheaper to reuse a canvas object than create a new one. So I've seen this before where you have certain sites, like imagine you have an image and you want to blow it up. So you want to draw image, your canvas, onto itself. But you want to move it into different places. So it has like a blow-up effect. Or likewise with a video. You don't want to draw image the canvas to itself because this is expensive, because you're creating new intermediates. Instead, you should create a hidden canvas or multiple hidden canvases. Do your draw image there, and then do your manipulation there, and draw back once. Okay. So while we were implementing IE9 using the D2D platform, we found some bugs, and I just want to call these ones out so it's clear what the issue is. So this is one of those cases where you wouldn't normally notice it. So avoid using geometric clips, rotations, or skew transforms when calling clear rect, because it'll be slower. And this is a part of that issue. Also, avoid doing clear rect when clearing paths on non-pixel boundaries. So this is an issue with Windows D2D platform. At some point, it may get fixed. I don't know, but you should be clear about this, and you should avoid doing these in these scenarios. Okay. My next tip is about avoiding changing attributes. So this one's kind of obvious. Don't change attributes unless you have to. But it may seem like the cost is small, but you should avoid doing all unnecessary DOM calls. Also, certain operations, certain attributes, for example, are slower to set than others. So only change what you need to change. Again, memory management, this is also good coding practice. Don't hold references to objects that can't get, so that they can't get garbage collected. Also, don't unintentionally cache graphics objects in globals or expandos. Do so intentionally, but don't do so unintentionally. Like, don't leave things lying around. Okay, so let's talk about timers. This one's kind of interesting because I've seen this widely abused on a lot of sites. So most monitors allow display frequency of about 60 hertz, which corresponds to 16.7 milliseconds. Some monitors, about 10% or less, have a display frequency of 50 hertz, which is about 20 milliseconds. So you can only draw as fast as the display can paint. So there's really no point creating a graphics timer that is faster than how fast your display can paint. So if we look at this example, on the top, I have a 16.7 millisecond interval that corresponds to my display. And on the bottom, I have a timer, a 10 millisecond timer, that corresponds to a graphics timer. Now, as you can see, at each draw operation needs to correspond with a paint operation, or I lose frames. So if I look at the timer at the bottom, you can see the first draw corresponds to a paint, so that's good. The second draw also corresponds to a paint. But the third draw, the one in red, before I could paint, I draw once again because the timer is fast. And the third draw actually never gets drawn. And repeatedly, you can see all the red draws don't happen. So what that results in is choppy animation. You're missing frames. So don't use a 1 millisecond timer. Don't use a 10 millisecond timer. Use a 17 millisecond timer. Now set timeout and set interval both take integer values. So just use a 17 millisecond timeout because there's really no value in using a smaller interval. It's choppy animation and results in reduced battery life. Okay, so that's cool. We talked about Canvas. We talked about when to use we talked about the scenarios that Canvas enables, accessibility features, interoperability differences. We talked about all that stuff. Let's talk about when to use Canvas. Okay, so HTML5 specifies two graphics models, SVG and Canvas. And any vector graphic, or almost any vector graphic, can be drawn with either technology, with varying degrees of effort. Some things are easier to draw in Canvas versus SVG. So I like to think of this as the spectrum of graphics. Now, I'm actually the Canvas PM, so I'll tell you everything's great in Canvas, use Canvas. And Jennifer's going to talk about SVG tomorrow, so you should probably go check out that talk. And she'll probably say SVG is great for everything. But the point that I want to make here is that you can use both technologies to complement each other. It's not really a comparison of which one's better versus the other. For example, using Canvas, you can draw SVG onto Canvas. Further, you can draw images, you can draw videos, other canvases on Canvas. Likewise, you can create a website that uses Canvas, SVG, and images together, complementing each other. For example, I showed the Killers website, the rock band. They were using Canvas and SVG. We have a few test drive demos where we use Canvas and SVG together. So I like to think of these as complementing technologies. Okay, so how many of you are familiar with SVG, heard of SVG? Okay, that's good. We have about, I'd say, a quarter or more of the room. So let me just briefly talk about SVG. SVG describes scalable vector graphics, and it's really just that, scalable vector graphics. It's retained mode as opposed to immediate mode, which means that SVG actually keeps objects in memory. So it remembers what was drawn last. As you remember, Canvas doesn't remember what was drawn last. Like HTML, SVG is built into the document. It has elements, attributes, styles. All right, so let's take a look. Let's describe the differences between the two. So Canvas is very pixel-based. I like to think of it as a dynamic bitmap. You have a script, and you can change the bitmap. SVG is very shape-based. Everything has a shape, and you specify shapes. Canvas has only one HTML element. SVG has multiple graphical elements that are part of the DOM. Canvas is only modified through script. That's the driver for Canvas. SVG can be modified through script or CSS. Likewise, the Canvas hit detection, the hit testing model, is very granular. The web developer has a lot of control here. You would create a mouse event. You check where the mouse is. You have the X and Y, and you can make decisions based on exactly where the mouse is. SVG, on the other hand, is a little bit more abstracted. You can give an event to a certain shape, so when someone clicks on a shape, you get the click event. So it's more abstracted to the shape. So performance is an interesting one. So on a in normal cases, performance is about the same on both. But in the limit, if you look at the limit scenarios, you have certain differences, certain characteristics. For example, Canvas doesn't care about the number of objects. Canvas just draws pixels. So if you had 1 million objects, Canvas doesn't know any different. It's just drawing objects. So it's a little bit better in drawing in scenarios where you're drawing a lot of objects. SVG, on the other hand, actually keeps track of the objects. So for SVG, it's a little bit, it's more difficult. Also, if you can imagine a scenario where you have a very large surface, in the Canvas case, the web developer has to clear out the entire canvas to draw the next scene. Now, it also depends on what you're doing and if you need or not need to clear out the entire canvas. But if you have a very, very large surface, and I'm talking about like not normal monitors, it's just to the limit if you think about it, Canvas needs to clear out each pixel. On the other hand, SVG doesn't. If one object changes, it'll change that one object. Okay, so let's take a look at the spectrum. So I like to think of this as the spectrum of graphics, and essentially, I'm just going to put a flag on scenarios that are easier to do in Canvas versus SVG. Again, this is not like one scenario versus another. You can use both technologies in a complementing way. Okay, so first of all, let's talk about screen capture. So this is the scenario where I'm saving pixels. It's like, imagine a paint application on the web. With the Canvas, as I mentioned earlier, you can do a to-data URL and save the exact state of the canvas. That scenario really doesn't exist in SVG. So if you're doing screen capture, you should use Canvas. Likewise, pixel manipulation. With Canvas, as we discussed earlier, you can update pixels for images, for video. So if you're doing video manipulation, you should look at Canvas. Okay, so for static images, this is a case where SVG is much better. You can imagine a scenario where I'm creating a corporate logo. Now, with SVG, no matter how much you zoom in or you blow up the picture, it retains its fidelity. Canvas, on the other hand, is just a bitmap. You only get the resolution of the bitmap. So at a certain zoom level, it won't look as good. Likewise, for high-fidelity documents, for viewing and printing, SVG is the key winner here. So scenarios where you have schematics or medical charts, SVG has an advantage. For complex scenes and lots of objects, I'd plant the flag on the Canvas side. Because if you have a lot of objects, Canvas doesn't care. It doesn't reference the memory. It just draws and forgets. So in a scenario where you're doing charting or graphing weather patterns, or actually have a map and you're putting a dot, different weather patterns, Canvas seems like a better scenario for that. Okay, so web advertising, this is a predominantly Flash Silverlight scenario today, but this also seems like a good scenario for Canvas. As I mentioned earlier, you can draw SVG, images, videos, all within the Canvas. So Canvas seems like a good candidate for web advertisement. For interactive charts and graphs, and also for 2D gaming, I'm going to put them both in the middle because there's no clear winner here. I feel like with SVG and Canvas, it also depends on the developer's background. You know, if you use VML or if you've done SVG before, SVG feels very comfortable. If you're new or if you've done like gaming development and you've played around with pixels, Canvas might feel a little bit more intuitive. So this depends on the developer. Okay, so let's talk about the calls to action. So what I hope is you guys walk away with two things here. And the first is you've all built applications with HTML and Flash and Silverlight. And why don't you, like you've heard what Canvas is, why don't you go home or work and give Canvas a try. You know, build a site with Canvas, try it out, check it out, see how it is. The second call to action is the future is hardware acceleration. So why don't you use IE9, develop your site, and make use of the graphics card. Okay, so I have a few minutes for questions. So I can take questions now, or since we're running out of time, you can actually come see me offline.